Hello, Algebra 1 students. I have worked the review problems for you. So if you worked those, you can check your answers here. But let's go on to remember when. Remember when you learned how to add fractions? You learned that they need a common denominator. So if we already have a common denominator of 100, we can just add our numerators and get 63 over 100. If we don't already have a common denominator, then we have to ask ourselves, 2 times what gives me the denominator of 4? Well, that'd be 2 times 2. But I don't have the right to just change the denominator. Remember, we have to multiply times 1 so that we don't change its value. So this turns into 2 over 4 plus 5 over 4. Now we have a common denominator of 4, and we end up with 7 over 4. For 7 and 8, there's not a number I can multiply times 7 to get 8. So we have to multiply the top and the bottom here by 8 and the top and the bottom here by 7 so that we can have a common denominator of 56. So we end up with 48 over 56, which is the same value as 6 over 7. I haven't changed its value, I just changed it so that I would have a common denominator. And then this gives us 35 over 56. So when we add our numerators, that's 83 over 56. And you always simplify fractions, but I don't believe that simplifies, so we will be finished. Well, these same rules apply when we are adding and subtracting rational expressions that aren't necessarily numbers like we were used to working with prior to algebra. So, to add or subtract rational expressions, we need like denominators. So we have to look for the least common multiple or the least common denominator. So let's see how that looks in an example problem. Alright, number 1, we already have a common denominator. So we have 4 b's plus 16 b's, so we have 20 b's over 15. And since it's a multiplication problem now, we can simplify that. And 5 goes 4, b, and 5 goes 3. So that's the simplified version of that addition problem. Here we have a common denominator of x minus 3. So on our numerator, beware of this negative sign. We have 7x plus 9 minus, go ahead and put a house around that couple, x minus 5. They're married. And so we have to distribute our negative sign. So be careful. 7x plus 9 minus x plus 5, because I've distributed the negative, which changed everyone's sign. And now when we combine our like terms, we have 6x plus 14 over x minus 3. And we can try to see if it'll simplify further by factoring out a 2, but that still leaves us with x plus 7 over x minus 3, and nothing will cancel. So that is your final answer. X plus 7, I don't know why that looked like a 17. X plus 7 when you factor the 2 out over x minus 3. I'm going to let you check your progress with those two and move on to the next page. When finding the least common multiple of denominators, or actually here we're going to be finding inverse denominators. So this should actually say inverse denominators. My bad, my mistake. So not least common multiples yet. That's coming up down here. First, the problem here is we have exactly the opposite sign. So what I can do is leave 3x over 11 minus x, and then because of this negative 5x, let's factor out, whoops, I can't write and talk at the same time today, negative 5x, bring out a negative sign, and that makes our 11 positive, and that makes our x negative. And then that can be simplified here. So that makes 3x over 11 minus x plus 5x over 11 minus x, because a negative over a negative, they're multiplied here, can be cancel each other out and become positive. So now we have a like term. We have 8x on top over 11 minus x, and that would be our final answer. So again, we have to do an inverse denominator. So this one's going to be a little more tricky because I don't have a negative on top. So it doesn't really matter which one you choose to do the inverse of. To be honest, I usually like for my n to stay positive. So this becomes negative n minus 4. So when we have a common denominator here of n minus 4, this negative and positive keeps everything together. These make the whole thing negative. So it's 8n minus n over n minus 4, because the positive and the negative turn negative. And when you subtract, you have 7n over n minus 4 as your final answer. Now we're ready for finding the least common multiple. So what is the least common multiple between 12b4 c to the 5th and 32 bc squared? So 12 is 3 times 4, b to the 4th, c to the 5th. And 32 can be broken down as 4 times 8. And I only have 1 b, and I only have 2 c squared. So the least common multiple is going to be, you have to have one of each. So you have 3 and 4 and 8, which when you multiply those together, 12 times 8 is 96. And b to the 4th, because b is a multiple of b to the 4th, and c to the 5th. So the least common multiple, you have to have a number that everything can go into. So the least common multiple that 32 and 12 can both go into is 96. And you get that by taking one of each factor and multiplying them together. So you have to have one of each. So you have to have all 4 b's and all 4 of the all 5 c's. So what is the least common multiple between these two trinomials? Well, this is going to require us to do some factoring. So let's see, multiples of 28 that subtract to give us 3. How about negative 7 and positive 4? Multiply to give us negative 28, add to give us negative 3. And then for the other one, it's same sign, both negative because of this positive sign. So it's got to be 7 and 1 because 7 is prime. And so our least common multiple, you have to take one of each. So we only have to take one x minus 7, but we have to take x plus 4 and x minus 1. So it's all 3, x minus 7, x plus 4, and x minus 1. That is your least common multiple. So I'm going to let you do the checkpoints 1 and 2 below. Alright, so before we tackle actually using our least common multiple to add rational expressions, let's run through our steps that we have here. Step number 1, you need to find the least common denominator, which is the least common multiple. Write a rational expression as an equivalent expression using that same LCD or denominator, and then add or subtract the numerators and write the results over the common denominator, and then always simplify fractions. And so if you can, simplify. So let's look at the next page. We need to find a common denominator. So let's see if we can factor multiples of 9 that will add to give us a negative 6. So 3 and 3 is my best guess. Same sign, both negative. So x minus 3 and x minus 3 would be the factor of. So when I go to find my least common denominator, I can't just do one x minus 3. I have to be able to satisfy both fractions. So the least common denominator is x minus 3 times x minus 3. Now for fraction number 1, this goes into it exactly 1 time, and 1 times x plus 7 is just going to be x plus 7. Plus, when I divide x minus 3 into this denominator, I'm going to have an x minus 3 left over, which I have to multiply times x plus 3. And that's where these get very hairy, I guess we could say. And we have to do our FOIL method right here. So x plus 7 stays put, plus x squared. Want me to do that in a different color? X squared minus 3x plus 3x. Oh, good. At least they're going to cancel, make a difference of squares, negative 9. So all of that is over x minus 3 times x minus 3. So when we combine like terms, we have x squared plus x, and then negative 9 plus 7 leaves us with negative 2. And that is over x minus 3 times x minus 3, which, now let's factor and see if we can cancel anything out. So this is x, multiples of 2, that's easy since it's prime, would be positive 2 and negative 1, that multiply to give us negative 2 and add to give us positive 1. And since there's not an x minus 3, nothing's going to cancel, so you can just rewrite this as x minus 3 squared. That's probably the best simplified way to write that answer. Alright, you may want to make sure you've copied this down because I'm about to erase it so I can have room to work number 2 for you guys. Alright, let's factor our trinomial y, same sign, both negative, multiples of 16 that add to give us 8. How about 4? Nope. Yeah, 4 and 4. 4 and 4 add. Okay, y minus 4. Good. So our common denominator is y minus 4 times y minus 4. I can't use just one of them because this denominator needs 2 of them. So my least common multiple is the 2 of them. So this goes once. So 1 times y minus 14 is y minus 14 plus, because of the sign here, it's a positive. And I have 1 y minus 4 left over when I divide this denominator into my new common denominator. And then I have y plus 4. So again, I see a pattern. This turns out to be a difference of squares. So this gives me y squared, positive 4y, negative 4y cancels, minus 16, all over y minus 4 times y minus 4. Combine our like terms. I have y squared plus y and then negative 30 over y minus 4 times y minus 4. Now, let's factor and see if any of those turn out to be y minus 4. So we need multiples of 30 that subtract to give us 1. How about 6 and 5? Oh, 6 and 5 are not going to cancel. So we have y plus 6, y minus 5, and since they're not a y minus 4, you'll just leave it y minus 4 squared in the denominator. Okay, I'm moving very quickly, but you can rewind at any point and watch that again. Alright, let's look at a word problem. For the first 15 miles, a biker travels at X miles per hour. Then, due to a downhill slope, the biker travels 2 miles at a speed that is 2 times as fast. 2 times as fast as his first speed. Write an expression to represent how much time the biker is bicycling. Okay, so A, for the first 15 miles, the biker's speed is X. For the last 2 miles, the biker's speed is 2x. Alright, we're going to be using the good old distance formula. Distance equals rate times time. And we're writing an expression for how much time. So to solve for time, you have to divide both sides by r. So that's where they get time equals distance divided by r. And r here stands for rate, not radius. And we're not going the same rate. So here's our situation. For our time, our first 15 miles, we're traveling at a rate, they told us, of x. X miles is our rate, x miles per hour. But then the last 2 miles, that distance, the rate doubled, so it's 2x. So here we have a situation where to make a formula, we need to be able to add. We need common denominator, so our common denominator would be 2x, because they both need to be able to go into it. X goes into 2x with 2 left over, so 2 times 15 plus 2x goes once, so plus 2. So that gives us 32 over 2x. That is our equation for our time. All right.